But it will, but it's basically we're going to look at the reverse of a power rule. And I'm going to talk to you about the X's and when they match, when they don't match, and that type of thing. So I'm going to make up a problem, and I'll just go ahead and tell you the rule. If you have u to some power, du, and the power is not a -1, then you will get u to the power plus 1 and the reciprocal out front. Plus a c. I mean, that's it. Looks real familiar because it's the same thing as your x rule. Okay, x dx. Same rule. You probably already know what happens if the power does equal -1. We'll write that one over here in a different color. So if the power does equal -1, then you get natural log absolute value of the u plus c. All right? But it'll be something in parentheses with a power. That's what you got to check out. Now, I'm going to show you why people screw up when they first start learning this, and I'm going to try to keep you on the road and in the right direction. On the Road, written by
Mr. Evans.
Kerouac. Read Kerouac, On the Road. Actually read Dharma Blum's Love More Fun by Kerouac. Dharma Blum's. Guys, you definitely want to read it before you go to college. All right, here we go. We have the integral x square root 3x squared plus 1 dx. All right. When I see that, I see the 3x squared plus 1 in parentheses with the 1/2 above it. See how that part's going to be in parentheses with 1/2 above it. So we'll write that in front. And then I'm going to take this x and I'm going to stick it out here on the end. Now, what I am hoping is that x is going to be part of my du. And when you first start learning these, it always matches perfect. That's not what's going to happen eventually. So don't think it's always going to happen perfect. Once you get it like this, you go over to the side of your paper and you write u equals the stuff in parentheses. Not with the power, just the part that's in parentheses. You write u equals that part that's in parentheses. You don't do it any other way. You don't go, oh, I don't need to write that. I'm so smart, I don't need to write that. You write that. Okay? You write it. Then, without even looking at this, you take the derivative of that. Don't look at this, just take the derivative of that. du equals 6x dx. And what you hope is that the x and the x match. If they don't match, it's not this easy. But as long as the variable here matches the variable here, then all you need to do is put a 6 in front of here and a 1/6 in front of the whole thing. The first thing we'll talk about is when the variables match up perfect. Then we'll talk about what happens if you have too many x's here. Like if this had been an x cubed or an x squared, what would you do? Or what would happen if there was no x at all? Because see, the first ones we're always going to work, the x's are going to match up. And that's what gets students in trouble, is they're so used to matching it up that they won't write this down, they won't write the steps. And so when we step up to the next level, you're crushed. All right, once you're here, you simply use the rule. You write your 1/6 down, skip a space. 3x squared plus 1, add 1 to 1/2. 3/2, put the reciprocal out front, 2/3 plus c. And so you get 1/9, 3x squared plus 1, 2 to 3/2 plus c. And that's what the original function was. That's what you took the derivative of to get that. Now, it's real easy to tell if students are doing this if they're not doing it. If you don't do this, that number right there is going to be wrong every time. Okay? And then you're going to spend, now remember, we're just doing this so that we can do applications. You don't want to do a 15-minute application problem and realize that your answer is 1/9 of what it should have been. Okay? Because, yeah, I'm going to start applications as soon as y'all get back from holidays. All right? No. Okay? Here we go. I have the integral. X squared, x cubed plus 1 fifth dx. First thing you want to do is rewrite it and put what you think is your u at the front. Rewrite it and put what you consider the u to be at the front. What does everyone in here think needs to go to the front? The parentheses part. Yeah, it needs to go to the front. I ordered $100 worth of markers from Amazon because the school gave us money to spend in our classroom, and I figured I needed markers more than anything else. So you're going to put that at the front because this is the part that has a power button. Somebody says, Mr. Evans, what happens if both of them have a power button? Not there yet. Yeah, this is the chumpiest form. Everything gets worse from here. This is the chump form. What are you going to do over here? You're going to write your u. What's your u going to be? Tell me out loud. X cubed plus 1. Then you take the derivative of that. Don't look over here. Take the derivative. What do you get? 3x dx. Then you look over here and you decide what number needs to go in there. 3. Because we're lucky. The x squared matches up with the what? X squared. See how the x squareds match? So all you need is a constant. And then follow your rule. So you do 1/3, skip a space, x cubed plus 1, add 1/6, 1/6 plus c. And that's how you do it. And the good news is, right there, the x squared, x squared. If those don't match, bad day. So far, so good? Yeah? Okay, well, let me before I just quickly erase. Question. You got a question. The biggest question people have is, why did the du go away? Because remember what put the du out there was taking the what? Derivative. You're undoing the derivative. You're reversing it. So the du is going to do what? Go away. All right. Now, put a pi in front of that just to mess with us. All right. Since that pi is just a constant, what am I probably going to do? I'm just going to move it out front. You can only do that with constants. But it just gets it out of the way. So I'm going to do that. Now, does anyone think, what is the u? What's, yeah, that's your u. And then see that 1 over square root of x? You're hoping that's your what? You're hoping that that is your what? Du. Is that okay? That's what you're hoping. I hope I made it up right, because I'm trying to make it up to where that will work. What am I going to do? I'm going to write down my u, and I'm going to take the derivative of that. And when I take the derivative of that, you might want to write x to the 1/2. It may make it easier for you. You get what? 1/2 x to the what? Negative what?
1/2.
Is that all right? Oh, look what that equals. du equals 1/2 square roots of x dx. So notice the great moment. Square root of x, square root of x. They match up. Everybody cool if they match up? So, what do I need here? I need a what right here? I need a 2. If I put a 2 in the denominator there, what do I need to do here? Put a 2 in the numerator. And that's what you hope happens. You're hoping that those variables always match. So then you get 2 pi, parentheses, add 1 to the negative 2, and then put the reciprocal of that out front, which is negative 1 plus. And there you go. This is u du integration. This is the beginning of the integrals. Got a test, nothing but integrals on it. A week from Thursday, March the 11th, Thursday. Integral test. Just going to give you integrals to integrate. All right. Folks, that is not a u du, because that will reduce and just be what? X plus what? Everyone okay? It'll reduce to that. Each 1 over x, use a little algebra. Fair enough. And then integrate that 1/2 x squared plus natural log absolute value of x plus c. And use the rule that I taught you a long time ago because we haven't been in school. Is that okay? So far so good? So that's not a u du. Lots of examples of this, making the x's match up perfect, that kind of thing. Let's do this. Notice that one's not going to reduce as easy, is it? Not going to, is it? Right? Take the part that's in the denominator and take that. And hope. Now, if you were learning this in college, the man would not even write anything else down. He would just write 1/2 natural log x squared plus 1. All right? He wouldn't even write anything else down, but I'm going to help you. Here's what they don't write down that I want you to write down. And you put a what here? A 2, and then you put what there? 1/2. Fair enough? And then your professor writes natural log of the square root of x squared plus 1 plus c. And that freaks you out, because it's really 1/2 natural log x squared plus 1 plus c. But what do you do with the 1/2? Brought it in and made it the power. Remember those 8 rules I taught you? Yes, they use those all the time. Now, to be honest, don't put absolute values around this one, because x squared plus 1 is going to be positive no matter what, isn't it? So everybody see how x squared plus 1 is positive no matter what? So don't put absolute values around it, because then you're redundant. That looks bad.
Where'd the natural log come from?
Okay, Power of what?
-1.
And if you have u to the -1 du, if you add the power rule, okay, you add the power, you get a what? 0. Bad day. That's your natural log situation. When you add u to the -1 du, that's what always gives you the natural log. All right? So far, yes, sir?
Would it matter if you simplified it to ln squared root x?
Doesn't matter if you leave it this way or this way.
Okay.
Just don't raise your hand and ask him how you got that if he just skips straight to there. Now, I'm going to write this like it's taught in modern times. I'm going to write the same problem taught in modern times. This is old school, what I'm showing you. This is what we did for years. What would happen in class if you saw this is your professor would go 1/2 integral du over u, and then 1/2 natural log of u, 1/2 natural log x squared plus 1 plus c. That's how it'd be written on the board as he's teaching it. Well, when he teaches it this way, you've got to realize he's telling you u is what? X squared plus 1. He's not writing it down over here. And then in his head, he's going, okay, the derivative of that's 2x, so I need a 2 here, so I got to put a 1 out here, a 1/2. You can follow what they're doing if you will write once you recognize what they're making the u, put it over here and do this. But that's the way it's done. They do substitution for everything. They turn everything into u's and du's. I don't do that. As long as the x's match up, I don't do all this scribble. All right? Whitehold didn't either. Stewart doesn't.
They just do that so they write less?
Yeah, they just see it, so they just see it. It's obvious that, and if you've already made an A on the first test, you can raise your hand when your professor says it's obvious that when someone asks a question, and say, you've been teaching it for 20 years. We haven't. It's not obvious to us. Don't tell him that if you made an F on the first test, which some of you are going to make because you're not going to do enough studying. All right? Okay. Well, I got x cubed integral square root x squared plus 1 dx. So I'm guessing the u is the x squared plus 1. And I'm hoping the x cubed is the du. And someone in here already knows that that's not going to be the du, is it? But don't skip what I told you to do. You go over here and you write u equals x squared plus 1. Du equals 2x dx. Because if you don't write that down, you won't know what to do next. All right. You got x cubed. Too big. Here's the deal, folks. There's either going to be a number here that's too big, or there's going to be too many x's. That's what I always tell kids. There's too many x's because there's x, 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 right? X cubed would be what? X, x, x. And you only need how many x's? 1. That power is too big. The power is too big. There's too many x's. Too many x's. This problem is special. You better be writing up there. This is a special. This is the next step. The x's aren't matching up for you. This is a problem that has what? Too many x's. Yeah, the x's don't match up anymore. It's not a perfect u du. We have too many x's. This is the biggie. Well, no. This is chump level 2. This is still chump. Until you finish this section, everything's considered chump. Okay, once you leave this section, you do some trig. It's a little bit more serious. But right now, this is chump level 2. tell you all that, but it's true. Okay? Now, I'm going to show you how to work this when you have too many x's. And in this case, you will make a complete substitution. You will turn everything into u's. So put too many x's. Turn everything into u's. Too many x's, what are you going to do? You're going to turn everything into u's. Somebody goes, Mr. Evans, there's another way. Yeah, but you don't want to you want to know the other way. So what I'm going to do, once I realize there's too many x's, I'm going to go down here below it, and I'm going to write x squared plus 1 to the 1/2. And then I'm going to take that x cubed and make it x squared x dx. Because that x does make part of my what? du. In other words, see, I got x cubed, and I only need how much for my du? I just need d what? X. So that's going to leave a what right there? X squared. Everybody good so far? Then I'm going to convert everything into u's and du's. So that's going to be u to the 1/2. Does everybody agree that's equal to u? Okay, so that's going to be what? U to the 1/2. And to make life easier, and I do suggest you get a pen that writes a different color to do this, or a pencil. If I'm tutoring students and I'm writing it, I write this step, and then I put the 2 here in a different color pen, and I put the 1/2 out front. You're not with your coffee yet. That is du. But the problem is, you got to figure out what to do with the x squared. Anyone got to guess what x squared equals? Tell me what x squared equals. Look over to the right.
U minus 1.
Yeah! That's the reason you're writing this down, is because you're about to need to do something with it. X squared equals u minus 1. Now, distribute this out and turn it into a polynomial. So you will get 1/2 integral u to the 3/2 minus u to the 1/2 with a du on the end. Notice you have u du, and they're both separated by a what? Minus. And I'll go ahead and tell you the book would put parentheses around that. But do you see how it's now a polynomial of u du's? U du, u what? Du. So you can integrate each one of them by itself. Now, before I step on to integrating them by themselves, I want to see if anybody's got a question up to this point. Yes, ma'am?
What happened to the x squared and the 2x?
Okay, the x squared is equal to u minus 1.
Okay, that's that part.
That's that part. And then the 2x dx, I did that so that the 2x dx would be the what?
Oh. Okay.
Du.
Okay.
And now, I only do them and substitute them into u's when I have too many x's. Your teachers in school will substitute them into u's all the time. I only do it if you've got too many x's, because there's no reason to unless you got too many x's. Okay? And that helps you kind of keep an idea. Notice, the x's were matching up, and now we got what? Too many. Now, when you integrate that, you will get u to the 5/2 with the 2/5 out front, minus u to the 3/2 with the 2/3 out front, plus the c. Just integrate each one of them using the little u du rule. Add it to the power, put the reciprocal out front. Then I get 1/5 x squared plus 1 to the 5/2 minus 1/3 x squared plus 1 to the 3/2 plus c. And what I do, I distributed the 1/2 out. And that is a pretty nasty one. That gets you out of chump land. Yeah, that gets you out of chump land. This is a step up from chump land. But this is something you're supposed to be able to do when you got too many x's. All right, somebody says, what happens if you have too few? You don't even want to know. Okay, too few x's, bad. Too many x's, oh. Now somebody says, what happens if that were just an x? Bad. A lot of bad things can happen, but this is the next thing you want to try when you have too many x's. Okay, this doesn't always work. You are now to difference between derivatives and integrals. For derivatives, you had rules. For integrals, you have methods. And you try a method, or you look at a method. If it doesn't work, you look at the next method. There's the too many x situation. So far, what do you think? Back row? Somebody said, do you want to take the derivatives and show us that works? No. But if you take the derivative of that and you reduce it down, you will get that. Pretty nasty little derivative. Okay, another question before I erase. Going once. Anyone? All right, now, let me give you one to work then. All right. Let's just make it kind of easy here for them. Let's not try to mess them up too bad. I have x times x, 3x. Let's put x. You don't have to mess them up too bad. Not right to there. 2x plus 1 to the negative 1 dx. How are you going to rewrite that? I'm going to do what? Well, what I'm going to do, yeah, it really started out like this. It really started out as x over what? 2x plus 1. And I'm trying to think this is my u right here, right? Okay, so I'm going to write it out. 2x plus 1 to the negative 1 x dx. I'm going to go here and write down my u. U equals what? 2x plus 1. Now we'll see what you tell me about it. Oh, yeah, the du is just equal to what? 2 dx. So you got to do a complete substitution because you got what? Too many x's. Okay, turn everything into u. See if you can turn everything into u now. And what tells me I got to turn everything into u's? I got what? An x there that I don't want. I wish it wasn't there because then it'd be a chump problem, but it's there. If that x wasn't there, this would just be the natural log of 2x plus 1, but there's an x in the way. So you got to turn everything into u's and du's. So, yeah, everybody's okay that if I put a 2 there, that makes my du, doesn't it? And everybody's okay, that's u to the negative 1. If I put a 2 there, I've got to put a 1 out front, 1/2. So what's going to go in that little set of parentheses right there?
U minus 1 over 2.
Say that again?
U minus 1 over 2.
Okay, I'm going to see if you're right. It's going to be, yeah, it's u minus 1 over 2 equals x. What do? You just solve for x so you can substitute it where? Back into that set of parentheses. Now, since that 2 is underneath both of them, guess what I'm going to do? I'm going to factor it where? To the front. So I'm going to get 1/2, and I'm going to get u minus 1. Now, once I get there, I just distribute this out, turn it into a polynomial, and I integrate each one. That's all you got to do. And that's what you do when there's too many x's. This is like, this separates some people out because the people that don't write the u du down never figure out what the x is, and they can't do integrals. All right, so you'll get 1/4 integral 1 minus u to the -1 du. And what happens when you integrate